Hi everyone, in this tutorial we are going to be talking about Newman projections. We're going to do a Newman projection overview. Now, it's really important to consider that in a compound, there is rotation about carbon-carbon single bonds, about sigma bonds. And we use Newman projections to consider this rotation about those single bonds, okay? And essentially what we can do when looking down carbon-carbon bonds is evaluate the types of steric interactions present. Steric interactions kind of generally refers to the penalizing, destabilizing energy that is introduced from the interactions of atoms and or groups, okay? We're going to say that the steric value or the sterics present in a molecule is the relative energy associated with a conformer or stereoisomer, okay? And think generally about sterics as meaning two groups and their electron clouds are kind of starting to interact, they're getting close, and that introduces energy to the molecule, okay? Now, we use Newman projections to represent compounds as viewed down carbon-carbon bonds. And what we need to do is be able to orient ourselves spatially here, okay? Now, it's really important that we understand if we're looking at this compound right now, we are a person here looking this way. So we kind of see this off angle and we see this point immediately towards our view there. So this is a sawhorse projection, okay? It's as if I took a compound like this and about the carbon-carbon bonds I rotated to then see maybe this carbon here as being the front carbon and that carbon there as being the back carbon, and I was able to see, the groups coming off of it, those other branch points. Perhaps they're hydrogens, and here you have methyl groups, okay? Now, if you were to rotate this front carbon this way, you would then see a Newman projection if we were this guy standing right here, okay? This guy standing right there. Now, in a Newman projection, the front carbon, so the one I'm making in dark gray, is this first radial spoke. And the back carbon we represent as a circle, okay? So that circle will be this back carbon here. The circle represents the back carbon, and the front radial point, this guy, represents the front carbon, okay? Really important for you to be able to familiarize yourself with that. Therefore, if I put A here, B, and C, we have A, B, and C. If on the back carbon I put on groups X, Y, and Z, then we have X, Y, and Z. And essentially, we can imagine rotation about either the front or the back carbon, and we can consider then the various conformations. Conformations refer to stereoisomers that interconvert as a result of rotation about carbon-carbon bonds. We can analyze a different conformation where maybe, A is on this side of X, okay, instead of being on the left side. We can rotate around to imagine different conformations. And you should be familiar with Newman projections and visualizing them, okay? And essentially, where we are in terms of viewing a molecule can really impact how we see it. If you were this person right here looking like that, you would have to take this front carbon and spin it this way and take the back carbon and spin it that way to see some type of Newman projection, okay? So we will be going over in the next videos how to convert from a perspective drawing into a Newman projection, as well as going through thinking about how we consider steric interactions in the various conformations of certain compounds like butane, and looking at how we can see differences in energy about rotating 360 degrees about the carbon-carbon bond. You will need to know how to convert to these Newman projections and how to identify this difference between staggered conformations and eclipse conformations, and then ultimately rank conformations, right? Rotating about the carbon-carbon bond, the different states that we could have. You will need to be able to use the relative steric ranking and penalty of the groups to determine the relative energies of those conformations. And just to clarify this, if you looked at these three compounds here, these are all conformations of each other. Notice that the bromine in each of the structures is interacting with a different group directly, okay? And we have these eclipse conformations, and we have staggered conformations. Notice how there's a gap here between those groups. They are staggered, as opposed to the groups literally being eclipsing. Now, these are technically right on top of each other, represented without the groups like that, But when you have groups, we kind of draw them close, but not completely overlapping, but it is understood that they're completely overlapping.